Hello everyone. In this video, we will discuss basic algebra and solving for simple linear equations. Before we talk about algebra, we need to know the basic language of algebra. The basic language of algebra consists of a few terminologies. For example, if I work with letters X, Y, A, B, C, any letters at all, if I involving them in my mathematical expression, I cannot call them letters, but they have a specific terminology which is called variables. Okay. Then the numbers that I use in my expressions, I can use integers, I can use fractions, such as -2, 5, 3/4, or negative fractions as well, then all of these numbers are called coefficients. So if I put a variable and a coefficient together, I will form a term. So therefore, the definition of a term is a term consists of both variable and coefficient. So you see in this case, I have x as a variable. In front of x, I have -2, so I have a term. And what you do is you interpret it as -2 times x. Okay? So the next term that I have, it will be -5/9, and my coefficient in this case is a negative fraction. So I multiply that with x. So 5 times b is a term, consists of coefficient as 5, variable as b, and -8 times c is coefficient is -8, the variable is c. So when I have a term, I can identify whether or not I have like terms or I have unlike terms. Okay, so unlike terms is more like different terms. So what is a like term? So like terms is when you have the same variables in your term. So if I have -2x here and I compare that with 3x, I have both of these terms as the same variable x, but they have different coefficients. So because they have the same variables, I can identify them as like terms. So unlike terms is when you have different variables. Okay, so I have -5x and -5y. So you see I have same coefficients, but I have different variables. So the important factor to identify my unlike terms is when you have different variables. So I have x here, I have y here, therefore I have different terms in this case. Or I can have 2b's and 3c, because b is different than c. I have different variables, therefore these are called unlike terms. Okay, they all have different variables. So the important rules that we have to remember is that in addition and subtraction, we can only perform these two operations if we have like term to work with. Okay, so for example, I would like everyone to perform the following operations as indicated. And as you see, you have 2x minus 5 minus 3x plus 7y minus 9 plus y minus x. So what we have is addition and subtractions, right? So we have addition and subtractions of all of these terms. They are terms because they have coefficient attached to a variable. Then I have to perform the operation as indicated. So all of these terms are just addition and subtraction. So we have to follow the rule that we can only perform with like terms. So therefore we need to find the like term in this expression. So let's find the first like term. So I have 2x. Okay, let's find a term that has the same variable. So I will have -3x. Make sure you include the sign in front of the coefficient as well, okay? And then I also have this as well, negative x. So if I perform this operation, you see that I leave the x as a variable. How do I get negative 2? I got this negative 2 by taking 2, subtract 3, subtract 1. Okay, so use your calculator, take 2, subtract 3, subtract 1. I should have minus 2 as the answer. Alright, so you have to keep the variable. You only add or subtract the coefficients. Okay, so what is the next like term? The next like term would be the positive 7y and then the positive y. Okay, so if you just have y on its own, the coefficient is invisible, and that invisible number is 1. So basically, you should read as 1y. So now I leave the y as the same variables. So what I have to do is I have to perform the operation associated with these two coefficients. So you have 7 plus 1. So in this case, I have plus 8, right? So therefore, I have plus 8. So let's see what else I have to perform here. So I have negative 5 and negative 9. So I can just go ahead and subtract these two numbers. So therefore, I have negative 14 as the result. Okay, so basically, we add and subtract. With algebra, we can only add or subtract with like terms. And for like terms, when I have the same variables, and if there's no coefficient in front of the variable, is in fact is a invisible number 1. Okay, so in this case, I should indicate to everyone that is invisible number 1 in front of this x. Alright, so let's continue with some basic properties and distributive rule of algebra. The very first important rule is called commutative properties of addition. So I have a plus b is the same thing as b plus a. So for example, if I have 2 plus 3, it's the same thing as I write 3 plus 2 because they both add up to 5. Okay? So the order in which two numbers are added does not affect the sum at all. So basically, you are having like an equation here. You have to make sure that the two sides is actually the same. And if you switch the position of any of these variable, you should have the same result. Okay. So the commutative property of multiplications. Okay. So in order to see that this is two equal to each other, I would like everyone to pay attention to a times b, and then I put equal sign and I said b times a. So what I did is I actually switched the position of these two. So commutative properties of both addition and multiplications is both saying that the position of this two variable does not affect the result. Okay, so if you multiply the two numbers, it's called a product. So in this case, if I take 2 times 3, so let's say I let a equal to 2, b equal to 3. So 2 times 3 is the same thing as 3 times 2, because in both cases, I have 6 equal to 6. Alright, okay. So let's talk about the next important rule. It's called the distributive rule. Okay. Distributive rule says that if I have a term and I multiply that with a two term inside the bracket, a plus b inside the bracket, this actually have a terminology called binomial. Binomial means two terms, okay? Binomial. So binomial means two terms. A plus B is a binomial. Inside the bracket, I multiply that with A. So distributive rule said that I need to take A times each of these inside the bracket. So therefore, I write it as A times B plus A times C. So let's take a look at our example number 2. Example number 2 said that I need to expand and simplify. So here you have a negative 5 and you have this inside the bracket. So I will take negative 5 and multiply each of this inside the brackets. So negative 5 times negative 2 should give me positive 10. Negative 5 multiply negative x. You leave the x as the same, but you multiply the two coefficients. So negative 5 times negative 1 will give you positive 5. Alright, so let's take a look at our next expression in this same equation right here. I have negative in front of a bracket and there's nothing there. So again, I have to put in the 1. It's invisible number 1. So therefore you take that, multiply with each term inside the brackets. Negative 1 times 6 will give me negative 6. Negative 1 times positive 1 in front of x will give me negative 1. So therefore I write negative x. Okay. So negative 1 times positive 1 will be negative 1. But I still have to attach that to the x. So in this case is negative x. Or you hear this all the time, right? You hear negative times positive x become negative x. But I cannot stop here yet because I have to identify the like terms and I have to perform the operation with the like term because this question also asked me to simplify. Okay, so in this case I found that this is the like term. So positive 5x subtract x will give me 4x. Positive 10 and subtract negative 6. This should give me positive 4. So 4 plus 4x is the final result. Alright. So let's get on with solving for simple linear equations. Okay. In solving for simple linear equation, we need to follow a few steps. So before I go over the step, I should define to everyone what is a simple linear equation. Linear equation is the equation involving an unknown that you have to solve for, but that unknown is actually raised to the exponent of 1. Okay, so that means you just simply solve for x. So you don't have any exponent associated with x, then it's called a simple linear equation. So let's start with the example. Okay, so first of all, I need to simplify both sides of the equation. So here's a step. Step 1, simplify both sides of the equation. But in example number 3, I don't need to simplify. Simplify means that you look for like terms, or if you have to perform distributive rule, then you have to simplify them first. Alright. After that, you can isolate the unknown by performing the same operation on both sides of the equation. It is an equation in mathematics. So equation means whatever you perform on one side of the equation, you must do the same thing on the other side. So this concept is called isolate the unknown. Isolate the unknown, it means you need the coefficient in front of x to be 1. Then step number 3 is you check the answer if it's required. So checking the answer, so by whatever you found for x, you substitute it into both sides of the equation to make sure that both sides of the equations are equal to each other. Alright, so let's start it with this example. So if I don't have anything to simplify, then I can go right away into isolating. Okay, so I have negative 7x equal to 35. In order for me to isolate the x, it means that I need to have just one x. In order for me to isolate and get rid of the negative 7 in front of this x, I have to divide both sides by negative 7. Okay, so because negative 7 times x in this case, so I will divide both sides by negative 7. Okay, now you see that negative 7 will cancel with negative 7 because negative 7 divided by negative 7 will give me positive 1. So in this case, x should be equal to negative 5. It's also very easy to recognize that x is equal to negative 5. But in this case, we should perform the step to familiarize ourselves with the concept of solving for the linear equation, because not all the linear equations are simple. Okay, so I would like to mention the check steps here. So that means you have to check left hand side equal to right hand side. So in this case, you should write that I found x as equal to negative 5. So you go back to your original equation and you substitute the value in for x. So it's negative 7. You times that with negative 5 to see if it's equal to 35, right? So you use your calculator, take negative 7 times negative 5. You should have 35 equal to 35. So both equations are the same. Okay. Both sides of the equations are the same. I should say that. Okay, so let's move on to example number 4. Okay, x divided by negative 3 give me 11. So again, I need to perform the operation so that I can isolate x on one side. It means I just have one x on one side of the equation. In this case, I divided by negative 3. Therefore, I need to multiply by negative 3 to both sides. Alright, so I multiply by negative 3 on both sides. If you divide it by negative 3 and you multiply by negative 3, it means this cancel out and you just have x left. So in this case, x is equal to a negative 33. Quite simple, right? Okay, so let's do the check. So in this case, if I check, I should have negative 33 divided by negative 3. Is that equal to 11? Yes, it is. So you can conclude that your left-hand side equal to right-hand side. Alright, so this step is important. I would like everyone to keep in mind that if you solving for a simple or any linear equation, it's a good idea to perform these steps here so that you know that you get the correct answer. Alright, so let's move on to example number 5. Okay, let's see. I have about 12 minutes left. Okay, so example number 5. In this case, what I would like everyone to think is step 1. Okay, simplify if you can. But simplify means you have to perform the operations where you have like term. So on the left hand side of this equation, I can see that I have negative 2x subtract 8. In performing the step of isolating, you need to isolate take away the negative 8 first. Okay, so if you actually use bad math to perform the operations for this particular expression, then if you need to isolate the x, you have to do the reverse. Okay, you have to do the reverse of that bad math. Okay, so let's go up here to see what I have here for everyone. Okay, so you have to do the reverse of that bad math. So you cannot isolate negative 2 right away. What I meant is you cannot divide it by negative 2 right away, but you have to get rid of this negative 8 first. Alright? So get rid of negative 8 means that you have to add 8 to both sides of the equation. So that's what I'm going to do. I'm going to take negative 2x, subtract 8, plus 8. It means I have to add 8 to the other side as well. And now you see that cancel that. So I get rid of the negative 8. And I have negative 2x equal to 28 left. Okay. So to get rid of the negative 2, I divide both sides of this equation by negative 2. Okay. So this cancel that as well. I end up with x equal to 28 divided by negative 2 should give me negative 14. Again, it's a good idea to check. Here's how we do the check. You need to write the left-hand side equal to the right-hand side. Underneath each of this, you take a look at what you see here. Right here, you see that. Okay, so you rewrite that left-hand side is negative 2x minus 8. The right-hand side is equal to 20. And I am having x equal to negative 14. So you are going to put in negative 2 times negative 14 minus 8 to see if it's equal to 20. So again, we need to obey the rule of order of operations. Order of operations said that I have to multiply first. So negative 2 times negative 14 should give me positive 28. Subtract 8 from that. I should have 20. So 20 equal to 20. Okay, very good. So again, this step is important. Pay attention to this. Excuse me. So let's work with example number 6. Example number 6. Before I can isolate any x, I have to simplify. Okay? Make sure that you remember that you need to simplify. Simplify for example number 6, I will have to apply the distributive rule. So in order for me to simplify, I will multiply negative 2 into each of these terms inside the brackets. So negative 2 times x will give me negative 2x. Negative 2 times negative 5 will give me positive 10. Okay, on the right-hand side of the equation, I cannot simplify anything yet. I don't have any like terms. So now your next step is to get rid of certain numbers in these expressions. So let's start with the left-hand side. Because in the end, you want your unknown x to be on the left-hand side, right? So you want to get rid of whatever surrounding x on the left-hand side, and then eventually it will take care of everything that you need to do by involving all the x on just one side of the equations. Okay, so let's work with this. So I have negative 2x. In order for me to get rid of the positive 10, I have to subtract 10. It means that I need to do the same thing on the other side of the equation. Okay, so I subtract 10 to both sides of the equation. Okay, so then in this case, I should cancel that with that. I have negative 2x left. Okay. Now, my next step here is to simplify my right-hand side. Because now that I subtract the 10, I can take this, subtract that. My answer should be a negative 21. Okay, now I add the x, but I can subtract the x here to get rid of it, and I can subtract x on the other side as well. You see, so I get that, cancel with that. You see, eventually you have x on the left-hand side. So combine these two terms, I should have negative 3x equal to negative 21. So let's write it on this side. Negative 3x equal to negative 21. Now I can divide both sides by negative 3 to get rid of the negative 3, so I can have the 1x. So in this case, I should have x equal to 7. Okay, so what I will do is I run out of space, so I will leave the check for now, and I will do that at the end when I have some time, if I have any remaining time in my limit of 30 minutes for this video. Okay, so let's move on to example number 7. Okay, for example number 7, the left-hand side is pretty simple, negative 3x minus 25. You cannot simplify that, but if you take a look at the right-hand side, there are quite a few operations that you need to perform. You need to perform the distributive rule here. Okay, so I will rewrite negative 3x minus 25. Excuse me. Okay, so on this side, 3 times x will be 3x. 3 times negative 1 will give me negative 3. Okay, now it's very important. I would like everyone to pay attention to the next step. Negative 2 times x will give me negative 2x. But when you take negative 2, pay attention to that negative sign, times negative 3 inside the brackets, it should give you positive 6. The common mistake many the students make is actually forgetting that it's a negative 2 in front of this bracket, and when multiplied it inside this bracket or applying the distributive rule, the student tend to forget this negative sign. So make sure that you remember that negative 2 times negative 3 give you the positive 6. Okay, so let's continue on. I should simplify the right hand side. This, simplify that, should give me 1x. I can just write x. This, add 6. I should have positive 3. So now what you can do is you can get rid of 25 on this side. So you add 25 on both sides. Okay, so I don't have any more 25. I just have negative 3x. On this side of the equation, you see that these two combined, you should have 28. And what I will do now is I will subtract x on this side so that I will not have any more x on the right hand side. So left hand side, combine these two, I will have negative 4x equal to 28. Now I will divide both sides by a negative 4. And this cancel out. And my final result should be x is equal to negative 7. Alright,